Hello, my name is Nathalie Toublanc. I'm Associate Director in the Learning Services Group at Simulation Plus. And as part of the GPX tutorial series, I'm going to talk to you about the multiple forms for the compound and solubility. The idea will be to consider an hypothetical compound, BCS class 2, so low solubility, high permeability, and to assume that we want to create an enabling formulation to increase the solubility, and we want to do some prediction with various percentage of the two forms. So the agenda for today will be how to set up multiple forms in the compounds view. Once this is done, using the multiple forms in the dosing view and also modify some of the characteristics of the two forms, and then to run the simulations for the three different formulations. Here you can see the properties of the hypothetical compounds and of the two forms of this compound, and now we are going to go into GPX. So we are going to create a new project. We are on the dashboard. To do that, we click on New. We go to the location where we want to save our project. For me, it will be under GPX multiple form. I select the folder, and then I will call the project multiple form. Then I just need to click on Create. And you can see that the project has been created because you've got the name on the right-hand corner, and also the navigation pane is active with green icon. So we are going to go into the compounds view, and here we are going to add a compound. We are going to call it compound X. I'm going to add the properties and consider a compound with a molecular weight of 300 grams per mole. And then entering the solubility. So as I was mentioning, form 1 will be a low solubility, so 0.01 milligram per ml. And this form will be used for the precipitation. I add a second form, which will be the form corresponding to the enabling formulation, and I'm going to go quite extreme with the solubility of 1 milligram per ml. So we are going to enter the biorelevant solubility. So for form 1, the SGIF solubility will be 0.1. The FACIF solubility 0.07. And the FACIF version 2 solubility 0.12. Now we can just use the drop-down menu to switch to form 2, and now I can enter the biorelevant solubility for form 2 for the SGIF 0.5, for the FACIF 1.2, and for FACIF version 2 1.5. For the pKa, we consider that this hypothetical compound will have one pKa, which is the base pKa, at 4 with a solubility factor of 10. However, for the pKa and solubility factor, we can only enter one model. So what we are going to do, we are going to use some observed data for form 2. So I'm going to the observed data view. For the data type, I will select solubility. I add a group name, which will be form 2. Okay. And then for the measurement time, solubility versus pH, and I call it sol versus pH. And now I'm ready to enter my data. So I've prepared some data for my form 2. Go to the cell, right-click and paste. And you can see now the profile for my form 2. So I go back to compound. And for form 2, I can choose the observed data profile. And you can see the observed profile with the dotted square. For the log P, it's 1.5, so moderately lipophilic. And then for the permeability of 2 compound is a BCS class 2. So now we can go to the dosing view. In the formulation, we are going to add a formulation, and it will be PO tablet F1. Okay, so we can see that this is correct. And now we can open the panel here, particle size and forms. And we can see that we've got our form 1. One thing we did, which is important in GPX, is that we need to have the same number of form in the dosing view and in the compound view. So in the compound view, we have 2 forms, so I need to add another form. So form 2, and we can see that the fraction of dose is 0 for form 2 and 1 for form 1, which is fine. This is what we want to do for our first formulation. Now what I'm going to do is I'm going to define the particle size. So for form 1, my API, I'm going to consider mean radius of 25 micrometer, standard deviation of 2.5, and a number of bin of 5. I could also change, if I wanted to, the shape factor, the density, the diffusion layer parameters, but I'm going to leave them as they are, but you know that there is this possibility. Then I'm going to go to form 2, and although it's not defined in this formulation, I'm going to use it for the other formulation, so I'm going to define as well the particle size. So if we consider that form 2 is a amorphous solid dispersion, we can consider that the mean radius is smaller. So I took 1/10 of form 1. So 2.5 micrometer for the mean radius and 0.25 for the deviation, and still 5 bins. So now this is defined, and we are going to create a new formulation. I'm going to copy that formulation because I characterized the 2 different forms. So I'm going to copy and just change the name to PO tab form 2. And now the only thing that I need to do for this formulation is to say that I want the fraction of dose for form 2 to be 1 and for form 1 to be 0. I don't need to do anything else because we've characterized the 2 forms. And I'm going to copy it once more. And this time I'm going to call it PO tab 50/50, meaning with half of form 1 and half of form 2. So now we have our 3 formulations that are ready. So we need just to create some dosing schedules for the 3 formulations. So I'll click on Add, and I will prepare 100 milligram tab F1. I just need to check that the formulation is the correct one. This is the case, so I'm fine. I'm going to copy it. Now 100 milligram tab F2. I need to change the formulation for that one to choose PO tab F2. And then I will copy it again to create the dosing schedule for the 50-50. So 100 milligram tab, 50-50. And again, need to make sure that the formulation is the correct one. So now we're finished with the dosing. We can move to the physiology. And we are just going to add one default physiology. So human, 30-year-old, 85.5 kilograms. This is the default physiology, so we don't need to change anything. We go to the pharmacokinetics view. And here we can change the FUP to 50%. The blood to plasma ratio is 1. And we are going to work with a one compartmental disposition model with a general clearance equal to 0.4 liter per hour per kilogram, and the central volume of distribution of 3 liters per kilogram. In the physiology schedules, the schedule has been created for our physiology. I'm just going to save. And then we can go to the simulations. Here, we are going to create 3 simulations, one for each formulations. I will call it sim 100 mg tab F1. So what I need to do is double check the configuration. So first, if I open, I can see that the compound is the correct one and the dose schedule is correct. Physiology schedule is the right one, and compartmental for the PK model. In the compound setting, everything is fine. I just need to estimate the liver first pass extraction. So I just click on estimate, and I've got the value. So here it's form 1 theoretical, so that's fine. And so everything is fine. So now I'm going to copy that simulation and do the same for form 2. I need to change the dose schedule to the dose schedule for form 2. And then I need to define the solubility model, which will be the interpolated one using the observed data for form 2. And finally, I'm going to copy it to create the SimTab 50-50. Again, I need to change the dose schedule to the 50-51, and everything else is fine. And I'm going to go to the runs. I will create one run for all the formulation together. I will call it all formulation. And now I can include my 3 simulation. Go to the bottom of the screen, and I can start my runs. And now we can see the impact of the forms on the concentration versus time profile. So if you want to see it a bit better, in the additional feature, you can click on the plus, and you can go to the color by simulation. And you click on color by, And if you don't like the color, you can change it. And once you find one that you like, that's done. So I showed you in GPX how you can include different forms for a compound. I limited it to 2 forms, but you can include as many forms as you want to. Now I would like to go over a few key points. So when a form is added into the formulation, by default, GPX will go to it. So you've got to be careful when you change the characteristic, like the particle size, to make sure that you're on the form that you want to change. The fractions are normalized when the simulation is run. For example, in our case, for the 50-50, I put 0.5 and 0.5, but I could have also put 1 and 1, and then GPX would have normalized it so that the total is 100%. One very important point, and I highlighted it in the presentation, is that you must have the same number of forms in the compound view and in the dosing view. If you don't, you will get a critical warning in the message center. The message is very clear, and you will be able just to add your form probably into your dosing view. What is very interesting in GPX is that your forms can vary in terms of solubility, both aqueous and biorelevant, and this is done in the compound view. You can also change the particle size, the distribution, the shape, the density, and the diffusion layer thickness and dynamics, and this is done in the dosing view. And finally, you can also have different solubility model, nanoparticle effect, bisalt effect solubilization ratio for your different form. And this will be done in the simulation view in the configuration panel. One important point as well is that the pKa and the solubility factor are not form specific. You can only have one set of pKa and solubility factor. So you need to decide on which form you want to feed them. Here, it would be on form 1, your API. And for the other forms, you will need to use observed solubility versus pH profile. So that concludes my presentation. If you've got questions, please don't hesitate to visit our website or email us at education@simulations-plus.com for training, and in the other email address for general information. Thank you for your attention.